Hello students, in this video we will be discussing about the spectral series of hydrogen atom. So we have discussed about atomic spectra, that is the formation of 7 different colors in a series, or the formation of black lines in a series. Similarly, to find that, let us find the value, the formula of that wavelength of the light emitted or the light absorbed by the gas kept in the gas tube. So from the Bohr's third postulate, we know that H nu is equals to E initial minus E final. So H multiplied to nu is equals to C upon lambda, and we know we have found the value of E is equals to minus 2 pi square K square M e to the power 4 divided by N initial, because we are talking about initial, that is therefore it is the initial orbit multiplied to the Planck's square of the Planck's constant. So minus and minus gets plus over here, and the same thing written over here. When we take the common thing out, we are left with 2 pi square K square M e to the power 4 divided by H square, and here 1 upon this plus 1 upon NF square minus 1 upon Ni square is kept over here. So this part, when H multiplied to C moves this side, becomes H cube into C, because H square into H becomes H cube and C. So this whole part is a constant, and that constant is known as Rydberg's constant, whose value is 1.097 into 10 to the power 7. And from this formula, different scientists have discovered different series. Like when hydrogen atom series was being, discovered, then Balmer was doing this, Balmer series. Now when hydrogen gas was kept in a tube and white light was being passed through it, he saw that in that spectrometer, dark line was being, drawn automatically. Obviously, that dark line, the first dark line he saw was a thicker dark line, and of wavelength 653.3 nanometer. But after some distance in that spectrometer only, he saw a thinner black line. Thinner black line means as compared to this black line was bit thinner. And the wavelength here was something around 486.1 nanometer. And again, when he moved to the left side again, he saw one more thinner line over there, and this thinner line is, this dark line was thinner to this dark line as compared to this. So, and the wavelength over here was 434.1 nanometer. And similarly, he saw few more, dark lines, and when he was moving to the left side, the smaller wavelengths, he was observing that the dark lines was being closer to each other. To find this phenomena, he first of all named all these things as hydrogen spectra for alpha particle, and not alpha particle, he named it as hydrogen alpha, and then he named it as hydrogen beta, hydrogen gamma, hydrogen delta, and so on. He named it. And when when he found the series, he found that the wavelength of this, from hydrogen atom only, we were getting so many different wavelengths. So he found that from this particular formula, when we put 1 upon lambda is equals to RH, this happened when he put the final position, it should be kept around, 2. When n final was kept as 2 square minus 1 upon n initial square. Here, initially, when the atom is being excited to the higher energy levels, let us consider here Ni is equals to 3, 4, 5, and so on. Then he found that this series was over there. And this series, which was observed by Balmer, was known as the visible region series. The visible region series. And similarly, few other scientists, like we will be discussing about Lyman and all kind of thing, we will discuss it now. Now, this was what Balmer did. Hello. Now, Balmer we have discussed. Now, what happened when Lyman did it? Lyman excited the atoms of the gas from initially it was for final it was n was equals to 1 and minus 1 upon n I ka square. And here in this case, when Lyman put the value of n final is equals to 1 square minus 1 upon n initial ka square, where n initial will be equal to either 2, 3, 4, 5. He got a different series, and that series fall under the ultraviolet region. Ultraviolet region. And then after it, Passion, and we studied about Passion series. Here, Passion put 1 upon lambda is equals to RH, and in finally it was in Passion series he kept the value 3 ka square minus 1 upon n initial square, where ni was equals to 4, 5, 6 and all, and this reason that he got was infrared reason. For infrared reason he got it. And similarly the other scientists like Brackett came and all. Brackett series, we named it as Brackett series, and similarly in this place he put RH multiplied by 1 upon 4 ka square minus 1 upon n initial square, where ni was equals to 5, 6 and all. And here when he got the series, it was again falling in the infrared region. He was finding the infrared region series only. And at last but not the least, obviously, it was P-Fund series. He did the same thing by putting 1 upon lambda RH, that is multiplied by 1 upon 5 ka square minus 1 upon n initial ka square. And here n initial was nothing other than putting the value 6, 7, 8 and all. And again here he found the series which was known as infrared region series. That's all with the video. Thank you very much for watching.